To solve this differential equation, take the Laplace transform every term. So this have Laplace transform of d2y dt squared plus 4 times Laplace transform of y equal to 8 times Laplace transform of delta impulse function of t minus 2 pi. Now, the Laplace transform of d2y dt squared is s squared times Laplace transform of y minus s value of y at 0 minus y prime at 0. That is for the first term. Plus the second term is 4 times Laplace transform of y. Equal to 8 Laplace transform of t minus 2 pi. What is actually over here? We get here unit impulse function e minus cs, where c is equal to 2 pi now. So this is e power minus 2 pi times s, right? So c equal to 2 pi now, and we take note that y0 is 3, right? y0 is 3 here, y prime 0 is 0, so this will give you 3, y prime 0 is 0 here, so eventually you get s squared plus 4 Laplace transform of y is equal to 3s plus 8 e power minus 2 pi s. Okay, so eventually you get Laplace transform of y is equal to 3s over s squared plus 4 plus 8 e minus 2 pi s over s squared plus 4. So we are going to find out what is y now, term by term. Therefore, y is equal to inverse Laplace transform of 3s over s squared plus 4 plus inverse Laplace transform of 8 e minus 2 pi s over s squared plus 4, and so you can take out 3 inverse Laplace transform of s over s squared plus 4 plus, take out 8 here, inverse Laplace transform of e minus 2 pi s over s squared plus 4. Now the first term, you can see that the answer is over here, cosine 2t, where a is equal to 2 now. So this is actually 3 times cosine 2t by from the first term. Now, the second term, we are going to use the second shift theorem. Okay, where is it now? So here, second shift theorem, which we are going to explore a little bit how to you do this, since this is a bit new to you here. So how do you do this? I'm going to study more in detail. Let's focus on this particular term, inverse Laplace transform of e power 2 pi s over s squared plus 4. From the second shift theorem, we know that f of t minus c times u of t minus c is equal to e power minus cs Laplace transform of ft. From the expression, my c is equal to 2 pi. Okay, so from my expression, my comparison, this one, you get 2 pi. So first thing, c is equal to 2 pi. So you should expect f of number 1. Number 2, the answer should be f of t minus 2 pi, unit step function t minus 2 pi. Okay? So what is f now? By comparison, f of 2 pi, okay, is actually, that means we know that ft now, the Laplace function of ft is actually this term. So let me see, you can write this in another way. This inverse Laplace transform of e minus 2 pi s 1 over s squared plus 4. So this is the part where you have f of x here. So this is right, Laplace transform of ft here. So this is Laplace transform of ft is 1 over s squared plus 4. Okay, by compiling this Laplace transform of ft is actually here. So from here, we know ft is equal to, by using the formula for sine 2t, right? So this is actually half of sine 2t, because Laplace transform of sine 2t we know is 2 over s squared plus 4. So I must multiply by half to get this one. So the final answer is we want f of t minus 2 pi. So f of t minus 2 pi, u of t minus 2 pi, which is actually half of sine 2 of t minus 2 pi, okay, and then u of t minus 2 pi, which you can simplify to half times sine 2t minus 4 pi, u of t minus 2 pi. Okay, so for this term, what you get answer is equal to half of sine 2t minus 4 pi times u of t minus 2 pi. But we know from trigo, right? Sine of 2t minus 4 pi is the same as sine of 2t. So this is actually half of sine 2t unit step function t minus 2 pi. So we copy the second term. This is equal to half sine 2t times unit step function t minus 2 pi. And then simplify it to 3 cosine 2t plus 4 sine 2t times unit step function of t minus 2 pi. That will finish the solution for example 11.